Hello, everyone. My name is Michael Oliver, and my project for this internship was working on cherry cultivar cold hardiness under the direction of Matthew Whiting and John Magny. To begin, every fruit starts with a flower, and every cherry starts with a bud. I know it goes without saying, but this step is, in my opinion, the most important as there wouldn't be fruit otherwise. Now, during this process, the bud needs to survive long enough in order to grow fruit. However, it is vulnerable to injury by cold temperature. This is where cold hardiness comes into play. Simply put, cold hardiness is how hardy or strong the bud is, which allows it to resist and eventually survive injury from cold temperatures. Hardiness will differ throughout the season, and it is already known which cherry cultivars or varieties are more hardy than others, but data hasn't really been collected for the exact cold hardiness. For my part of the project, we wanted to speed up how cold hardiness was found by using machine learning. So, how did we measure cold hardiness in the first place? Well, unfortunately, I wasn't there for this step, but John Magby set up this system where he attached thermal electric module sensors to different cherry floral buds in small boxes to measure the electrical flow of them. Afterwards, he put those inside a programmable freezer where the temperature of the freezer and the frequency of the sensors were collected every 15 seconds. Here are the thermal electric module sensors that were hooked up to the buds, and below is the freezer that the buds were put into on trays. Once this was done, John then converted all the data, which just came in as a bunch of numbers in an Excel sheet, to a graph. The peaks represent a change of electrical flow as a result of heat of fusion, which happens when the water inside the bud is completely frozen, meaning the bud is dead. From this, he was able to find the temperatures at which the buds died, which I received and used to create an Excel sheet to give to a machine learning algorithm in the coding language R that we found online from Jason Brownlee on machinelearningmastery.com. The picture shown here gives a quick example at what data the machine learning needed, which includes the temperature of the freezer and the frequency of the sensors, rate and rate 2, which is the voltage between a 15 and 30-second interval, respectively. We set each point as either blank, meaning not important, or LTE, meaning low temperature exotherm, aka when the bud died. We also included cultivar and date, since, as I previously mentioned, have an effect on cold hardiness. We tested three different types of models, those being classification and regression trees, support vector machines, and finally random forest, which we found to be the most accurate for this project. Random forest creates what is called decision trees that choose one point to start on and branches off from there, using different uncorrelated models to get an average output from the trees. With this model, we then gave the machine learning algorithm a fresh set of data to score, which we then compared to how John scored the data. This Excel sheet gives a quick example and a small snippet of how the algorithm scored, and from a quick glance, it's visible that it was fairly accurate. Blue represents false positives the machine scored, aka it said an LTE was there when it wasn't, red is false negative, and green is correctly scored to what John scored. From that output, we then used a tool in R called Nova to see how well the algorithm compared to human scoring. At the bottom, Chelan H stands for Chelan human graded, while Chelan M stands for Chelan machine graded, so on and so forth. What's important to note here is the differences between cultivar ranges, which are the vertical lines. Our algorithm found that while there was no significant difference between machine and human graded cultivars, there was a significant difference between the different cultivars, specifically Chelan and Regina. meaning that the machine is able to identify that different cultivars have different mean cold hardiness. As for the possibilities of this project, the next step would be to speed up the process by writing code, which would automatically format the date so the machine can easily read and process it. This would help lead to the development of reliable cherry cultivar cold hardiness at any location, which would then be integrated with modeling hardiness. By doing so, farmers would know the average temperature at which flowering buds die, which would help prevent crop loss, such as by running heaters for a cultivar at risk of frost damage. Additionally, breeders can then find a cherry cultivar with a cold hardiness that fits whatever project they're working on, take what makes that bud hardy, and use it to create a new variety with similar cold hardiness traits, as has been done with firmness, size, etc. By mixing computer science and more specifically machine learning with agriculture, we would be able to collect important data at a speed that hasn't been done before.